Hey, this looks familiar. We started our unit talking about solving systems of linear equations. And so if I had this, I would say, all right, I'm going to solve this using substitution or elimination. For this one, either one would work equally fine. But what happens when we have larger equations? Well, a simple way to do this is to solve this using matrices. So when we solve this using matrices, we're going to define three matrices. The first is going to be the matrix of coefficients. So if I have all my coefficients, that's going to be 5, 3, 2, and -4. Notice this follows pretty much the same position that they are. Like if I were to drag this right on top, they'd be in the same position. So our size of the matrix is really going to depend on what our equation is. Now the next equation we're going to have is going to be our matrix of variables. What are our variables? Well, we have x and y. And so if you think about multiplication, this is actually multiplication. Notice here I would have 5 times x plus 3 times y. Well, that's what I have. And then the other matrix is our matrix of constants, so our solutions, which is here 9 and 14. So for this, it's very important that our linear equations are in standard form, ax plus by equals c. If they're in any other form, then we need to change it to this. Now, as I've previously hinted at, here, if we just had 5x, we would divide both sides by 5. So lots of people think that what we do is we actually divide by the matrix, but we can't divide matrices. So instead what we do is we multiply both sides by the reciprocal. So here I'm going to have, so let me use my same colors, I'm going to have that xy is equal to the inverse of 5, 3, 2, -4 times our matrix of constants. Now x and y are isolated, so all I have to do is multiply. Well, this is great. So let's actually do that. This is the inverse. How do we find the inverse? Well, it's going to be 1 over, this is -20 minus 6 times, over here, this is going to be -4 and 5, they switch, into -3 and the -3 and -2. And then we have 9 and 14. So this here, -20 minus 6, that's -1 over 26. So we distribute this in, and we're going to get, if this is a -26, -4 over -26 is +2 over 13. We're going to have a +3 over 26. We're going to have a +1 over 13. And we're going to have a -5 over 26. And we're going to multiply this all by 9 times 14. This is going to give us x and y. So we could work this out. Most of the problems I'm going to give you are going to be some nice integer values to work with, but we can actually use our calculator to check this. And actually what we could actually do here is we could put this equation right into our calculator. So if I have two matrices, if I go to my matrix submenu, I'm going to edit my first matrix as this right there. So that's going to be a 2 by 2 matrix. And so I'm going to have a 5, 3, 2, and a -4. Whoops. -4. So I have that matrix selected, so I'm going to back out. I'm going to go back to my matrix menu. I'm going to edit, and create matrix B now. So matrix B is this. That is a 2 by 1 matrix, 2 rows and 1 column, and it's just 9 times 14, or 9 and 14. Okay? Just like that. So how does my equation look? Well, it looks like it's the inverse of matrix A times matrix B. There we go. 3, negative 2. So if we could just continue with all these ugly fractions, we would have actually gotten that. So we get xy is equal to 3, negative 2. What does that mean? It means that x is 3, y is negative 2. Well, we can check this out. So here we have 15 minus 6 is 9. Yes, it is. And then we also have 6 plus 8 is 14. This is our correct answer. And we got that just by using our calculators. Now, I know some of you might think, well, it would just probably be quicker for me to use substitution or elimination here. So instead, what we could do is we could apply it to the problem like this, where now we have 3 variables, 3 equations. If you want to use substitution or elimination, that's fine, but setting it up this way is actually a lot easier. So first we have our matrix of coefficients, which is going to be 2, 3, 1, 3, 3, 1, and then 2, 4, 1. And we're going to multiply this by our matrix of variables, which in this case is x, y, and z. And this is going to equal our matrix of coefficients. So negative 1, 1, negative 2. So actually, when we have our new equation, it's going to be x, y, z is equal to the inverse of that matrix, so that's to the negative first, times negative 1, 1, negative 2. Now don't forget, we actually did not cover how to find the inverse of a 3 by 3 matrix. So instead, what we need to do is we need to use our calculator. So I'm going to go back. I'm going to actually write over matrix A. So I'm going to do a 3 by 3 matrix now, and just make sure I put in these same values. So that's going to be a 2, 3, 1, 3, 3, 1, 2, 4, 1. Quit out. Go back to the matrix menu, over to Edit, go to matrix B now, and this is a 3 by 1 matrix. And it's a negative 1, positive 1, and a negative 2. Quitting out. What I can say is I'm going to go to matrix A to the negative first times matrix B. And look at that. 2, negative 1, 2. So for such a crazy problem here, x, y, z is equal to 2, negative 1, 2. I think that's what it said. Oh, negative 2. So for such a crazy problem, we actually get a fairly simple answer. 3 integer values that we can just plug in here. So I'm actually running a little bit low on time, but we can do that with these as well. And so just make sure that you can follow along with how to do these. Actually, I do have some time. So with this, the setup for these, it's just going to be xy is equal to the inverse of the coefficient matrix. So 1, 3, 1, negative 1 times the matrix of constants. Over here we have 3 variables, so x, y, and z. And so this is going to be equal to the matrix of constants. Now, x, y, z in the first row is 3, negative 2, 1. But in the second row, it's 3, -6, and 0. Be mindful, there is no z here. So what we need to do is we actually need to replace and say that z has a 0 coefficient. And over here we get a -5, 4, -3. And we multiply that by -1, 0, and 9. So if I go to this first problem here, I'm going to again write over these same values. Not really recommend it if you're doing a test, and actually I'm going to do the other two. So this is a 2 by 2 matrix, and we get 1, 3, 1, -1. Quit out, go back to that menu, and I'm going to edit matrix B, which is now a 2 by 1 matrix, and it's 6, 2. So if I just type in exactly what I had typed in before, look, I get 3, 1. So I get that xy is equal to 3, 1. And because that's our intersection point, we're going to write that as 3, 1. Now for number 2, I'm actually going to use some new matrices. I'm going to say I have matrix C, which is that 3 by 3 matrix. And so this is 3, -2, 1. So 3, -2, 1. 3, -6, 0. And -5, 4. -3. Yep. I'm going to quit out. Go back to matrix. Do matrix D now. This is a 3 by 1, and our answers are -1, 0, and 9. So all I have to do is say, all right, I'm going to have matrix C and take its inverse, and I'm going to multiply that by matrix D. 2, -1, 2, 1, -5. So that means that x, y, z is equal to 2, 1, -5. Yep. So 2, 1, -5, that's our answer. We can go back and check this, and if you want to, you can check it out. But that's exactly what we need to do. So check this out. Be familiar with your calculator, get some good practice in, and we will review in class.